Hello, good morning. I'm discussing about electrical properties of colloids. The properties helps to know about the change on colloidal particles in dispersion medium, colloidal dispersion, electrophoresis. When an electric field is applied on colloidal dispersion, then the particles carrying charge moves toward opposite charge. See, this is the cathode and anode. The positive colloidal particles are moving toward the cathode and negative are moving toward the anode. The electrophoresis may be defined as the migration of the charged particles through the solution under the influence of an external electrical field. Ions that are suspended between the two electrodes tends to travel towards the electrodes that bears opposite charge. Principle, any charged ion or movable migrates when placed in an electric field. The rate of migration depends upon its net charge, size, shape, and applied electric field. V equal to EQ over F, the velocity of the molecule, the electric field, Q net charge on molecule, yeah, frictional coefficient, which depends upon the mass and the shape of the molecule. Factors affecting the electrophoresis: sample, charge, rate of migration increases with increase in the net charge, size, rate of migration decreases for larger molecules. It is due to the frictional and electrostatic force. Shape, molecules have similar charge but differ in shape, exhibit different migration rate. Electric field voltage, increase in voltage leads to increase in the rate of migration. Current, increase in current leads to increase in voltage, migration also increases. Resistance, resistance increase and migration decreases. Buffer, ionic strength, rate of migration increases in high ionic strength. Phase, ionization of organic acid increases as pH increases. Supporting medium, adsorption reduces both the rate of migration and resolution of surface molecule. Electroosmosis, it is due to the presence of charge groups on the surface of the supporting medium. Preferred carboxyl group, agarose sulfate group, it will accelerate the movement of cations but retard the anion movement. Electrical double layer, origin existing at the boundary of two phase and assumed to consist of two opposite charge layers, such as the layer of negative ions adheres on colloidal particles that attracts a layer of the positive ions in the surrounding electrolytic solution. Or the electrical double layer is a structure that forms at the interface between a charged surface and an adjacent liquid containing ions. It describes how charge on the surface are balanced by countercharge in the liquid to maintain electrostatic equilibrium. Electrical double layer consists of a strong layer and diffuse layer. Inner layer, stern layer is inner layer. The stern layer accounts of ions finite size and consequently an ions closest approach to the electrode is on the order of the ionic radius. This is stern layer, inner layer. This is the inner layer. This is the inner region are the adsorbed ion due to a chemical interaction. Cations are adsorbed by the negative surface, counter ions opposite charge cations. Diffuse layer, the diffuse layer is a thin layer of the electrolyte solution close to the charged surface or stern layer in which the solution acquires a local space charge density due to accumulation or depletion of the dissolved ions. This diffuse layer, this is the diffuse layer, outer side. This layer is loosely associated with the layer. This layer called bulk liquid layer. There are excess of negative ions after uniform distribution. So compact layer, this is the diffuse layer, this is the neutral. The layer is loosely associated with layer and also called bulk liquid layer. There are excess of negative ions after distribution. It is only about the electrical properties of colloids. Thanks for watching. Thank you for the patient that is now. Bye bye. See you again.